Alright, in this video we will be talking about disjoint sets. That is one thing, disjoint sets. And then I'm going to talk about difference of the sets, difference of two sets. That is first part, which I'll be talking about. And probably in the second part, I will be talking about, what difference of two sets. Please excuse me for spelling if something goes wrong. Difference of two sets. So these are the two concepts which I'll be taking up: disjoint sets and uh, difference of sets. So let's actually talk about first of all that how this entire thing works of disjoint sets. I'll straight away jump into the examples. Before that, I will show you a Venn islet diagram how exactly the disjoint set works. So disjoint sets are these two sets, like this set A and this set B, nothing in common. Two sets A and B are disjoint if their intersection is phi, null set. That means there is nothing in common between them. So then A and B are called as disjoint sets. So we have to verify, let us suppose, certain sets whether they are disjoint or not. I'll take first example, let's say, and this first example says you if you have a set A called 1, 2, 3, 4, and you have got another set B which is called as x such that x is a natural number, x such that x belongs to n, a natural number, and something like this. That means 4 is less than equal to x is less than equal to 6. That means x varies from 4 to 6, including 4 and 6. And whether I have to see whether A and B are disjoint or not. So for that, let me write B in the tabular form. Once again, it is given inside builder form. So B is going to be 4, 5, 6, right? It's a natural number. 4 is included, 6 is included. Okay, let's calculate A intersection B. Is there something in common between them? Yes, the 4 is in A, 4 is in B. That means A intersection B is 4. That means it is not equal to the null set. This means what? Therefore, A and B are not disjoint. Why not disjoint? Because they have something in common. They have, you know, their intersection is not phi, so they are not disjoint. Let me take another example, let's say. So if I have got something like I have got a set X which is saying A, E, I, O, U, again a set of vowels, very common set which generally people take again and again. And I have set Y which is C, D, and E. So, and again, I have to check what is X intersection Y. Is it null or not? A, okay, it's nowhere. E, yes, it exists here, E. So if you see E is a intersection element here, again it is not equal to phi. It is not equal to phi. Therefore, X and Y are okay. Let me write it again. X and Y. Okay, let me write it in a better way. Let me clean it up. Fair. Good. So X and Y are not disjoint because I got something in common. It's not like that they are completely different from each other. Let us see one more example. This time I've got something called x is equal to x such that x is an odd integer. X is an odd integer. And I've got a set y which says x such that x is an even integer. So you can simply see if I tabulate them how x is going to be. X is going to be an odd integer. It is going to be 1, 3, 5, and so on. It is going to progress something like this. And y simply is going to be an even integer. So 2, 4, 6, and of course in both direction plus and minus. So it is not mentioned it's a negative integer or positive integer. So it's going to be, let's say, plus minus 1, plus minus 3, plus minus 5, plus minus 2, plus minus 4, plus minus 6, and so on. Right now I'm taking only positive integers, let's say. Now, if you see, there is nothing in common. So if I see X intersection Y, that is completely null set phi. Therefore, I would say that X and Y are disjoint. Okay. So pretty common. I just need to see whether, the two sets have something in common or not. If they do not have nothing in common, you can simply say that these are, disjoint sets, else they are not disjoint. Let me take now the difference of sets. Let me take one example. If I have a set, let's say A is equal to 3, 6, 9, 12, 15, and then I have got 18 and 21. These are the elements of set A, and then I've got a set B. Then I've got 4, 8, 12, 16, and 20. Certain elements are there. And there is a set C, which says me 2, 4, 6, 8, 10, 12, 14, and 16. Now, I just want to find out, first of all, what is A difference B? Now, how do you find A difference B? Let me give you a little idea about it. A difference B is X such that X belongs to A and X does not belongs to B. If you want to show it through a Venn diagram, and if there are two sets, one is set A, other is set B, let's say, then the portion which I'm going to shade, let me pick up a different kind of color pen here. The portion which I'm going to shade is going to represent A difference B. This is simply A minus B, where this is set A, this is set B. Why? Because it is considering only the elements of A, not the elements of B, and even not the elements which are in common. So let me pick it up A minus B here, how exactly this A minus B is going to work. Then A minus B is going to be elements of A, not the elements of B. So I see 3 and it is not in B nowhere. Okay, I'll write 3. I see 6. I carefully check, is it existing in B? No, I'll write 6. I see 9. It is nowhere in B. I'll write 9. Then 12. It is in B. Oops, here, red flag. I'm not going to consider it. 15. Can you see? It is nowhere in B. I'll write once again. 18. Okay, nowhere in B. Once again, green light. 21. Once again, nowhere in B. And yes, it is again welcomed. So this is A minus B. I just write one more particular part, let's say A minus C you want to see. So again, you start checking what is exactly in A and not in C. 3, okay, not in C. I can put 3, 6. No, yes, it is in C, so I cannot put 6. 9, okay, it is nowhere in C, I can put it. 12, it is in C, I can't put it. 15, I can see it is not there in C, so I can simply put 15. And 18, if you see the next element 18, it's nowhere in C, I can still put it. And then comes the 21, nowhere in C, I can put it. Interestingly, how the results actually differ, let me pick up another color and let me show you one more interesting piece here. That if I want to find out C minus A, now my elements would be the elements which are in C, not in A. So how do I go about it? First element of C is 2. I need to check, is it existing in A? No, so I'll write 2. Second is 4. Is it existing in A? No, I can write it. Third is 6. It also exists in A, so I'm not going to put it. 8. It is nowhere in A. I'm going to put 8. Next is 10. 10 is nowhere in A. I'm going to put 10. Then 12. It exists in A, so I'm not going to put it. 14. Nowhere in A, I can put it confidently. 16, nowhere in A, I can put it. So you can verify this particular thing from these two outputs. That's it, not necessary the difference of two sets is absolutely same. So that is what A minus C and C minus A is about. Okay, I can take some examples where the members are actually not represented through uh, numbers, probably through some text. So let me just take one more example here. And let me see exactly one more example I'm going to take up. If I've got a set X which is actually saying A, B, C, D, and I've got a set Y which is actually giving me F and then probably B, D, and G. So I've got a set X, a set Y, and I want to calculate something called X minus Y. And that is simply going to be A, it is nowhere in Y, I'm going to put it. B, it exists in Y, so I will not take it. C, it is nowhere in Y, so I put it. D, it is there in Y, so I'm going to put A, X minus Y is A into C. While Y minus X is going to be, first I'll start taking elements of Y. F, it is all in Y, not in X. B, I cannot put it, it exists in X. D, it exists in X, I cannot put it. And G, yes, it is in Y, but not in X, so I'm going to take F and G here. And if you see, I see X intersection Y here, then they are exactly what, if you see what are the common elements, B and D. These are the two common elements, right? So I'm going to write it X intersection Y is B and D. So identically, if you see, the common elements or the intersection is nowhere coming in X minus Y or Y minus X. So X minus Y doesn't have whatever elements are in the intersection, and Y minus X also doesn't have any particular element that belongs to intersection. Thank you very much.